Hi, welcome back to JupyterCon and welcome to my talk. My name is Damián and today I am going to take a little bit of your time to talk about how we are using tools from the Jupyter ecosystem, what I call the Jupyterverse, to power and sustain the MADS program. But let me first start with a little bit of self-introduction. As I said before, my name is Damián Avila. Here you have links to my technical blog and my Twitter and GitHub handles in case you want to be in touch with me. I'm actually a Jupyter core developer, a Jupyter Steel Council member, and I have been part of the Jupyter project and the Jupyter community since 2012. A lot of years have passed since that, yeah. I am also currently a senior software developer at the UNC MADS Tech team. That is the team supporting the MADS program from the School of Information at the University of Michigan. But maybe you are wondering, what is this MADS program about? This is actually our new fully online master program in applied data science. This is our second year. A few weeks back, our second cohort of hundreds of students started. So if you are interested in applied data science, I will highly encourage you to visit that link, know more about the program, and eventually become one of our new students. But let me go back a little bit in time and actually go about maybe 1 year and a half ago. And at that time, we were actually starting from scratch from the tech perspective. And we as the tech team faced the problem to design and implement a scalable and standardized system. So our instructors, faculty, teaching assistant, what I call the content creators, could actually develop not only lectures but also programming assignment and autograders in an easy way. And I want to highlight two things here. We wanted to implement a scalable system because we are actually supporting dozens of courses, and we also wanted to be a standardized system. So our content creators can actually familiarize themselves pretty quickly with the system and leverage on top of that, and eventually create content for several of our courses. So those were two primitive and main ideas at the time to come up with the design and eventually the implementation. But at that time, we had a very well predefined context with one of the most important thing was the fact that we were and we are still working with an LMS platform partner called Coursera. Maybe you heard about them. And they are actually providing the computational resources that students use. So we need to keep that in mind at the time to create our design and to implement our solution. Just keep that in mind for the future slides. But another thing I want to highlight, and you will see that this idea will permeate my whole talk, is the idea of workflow, and specifically the MADS stage workflow. This is a linear multi-stage workflow that actually permeates not only this talk but also our own infrastructure and allow us to actually create content and actually put that content in front of our students. So keep that idea in mind, and I will try to describe the workflow at the same time that I also describe some of the pieces of our system. At the time, we saw the opportunity to create this sort of decoupled workflow system where instructor could create the content in a rich, customizable but standardized environment. And there are several pieces here. We needed a decoupled system because we were and we are working with an LMS provider. We wanted our instructors to have a really rich and powerful experience, but also an enough customizable because we had pretty different courses. And we also wanted to have a standardized way to interact with that environment so they can actually leverage on that shared knowledge. But we also wanted the system able to create something, to create an artifact that contains the specification of the environment that will be eventually deployed at our LMS platform. Actually the real content, I mean the actual content the instructor have developed. And finally, we wanted a system that once the artifact has been deployed, it could provide the course customized environment in front of the students and run eventually the autograder once the students submit their programming assignments. So, in summary, we saw the opportunity at that time to create this hybrid decoupled system as a sort of modular infrastructure that not only allows us to interact with the current LMS, but also could be easily adapted for other LMS or even other degrees. But one of the decisions we have taken at the very beginning, and we are proud of that decision, and we are very happy about that, is the decision to build on top of tools from the Jupyter ecosystem. As you know, Project Jupyter exists to develop open source software, open standard, and services for interactive computing. And in the whole degree, in the whole program, we actually not only embrace the Jupyter Notebook as one of our main things, but also other Jupyter tools such as nbgrader. You will see that pretty soon. But essentially, we have decided at that very early point in time to actually embrace the Jupyter community and the Jupyter ecosystem and build our solutions on top of that ecosystem, which is pretty powerful and allow us to do pretty nice and also powerful stuff. But let me start from the very beginning of the workflow. And as we go forward, I will describe the next stages alongside with some of the pieces of our architecture. Let me start with this first concept, which is our course development environment, which is one of the main things in our develop stage. We wanted, and we actually did it, to provide a rich, customizable, but standardized environment. Remember, rich, customizable, but standardized. So our content creators can actually deliver and create their content. And to provide that, we use our own heavily customized Kubernetes-based JupyterHub deployment on Amazon Web Services. That deployment is actually based on the Zero to JupyterHub with Kubernetes guide, which is an awesome guide produced by the JupyterHub team. If you are interested in deploying JupyterHub on top of Kubernetes, please read that guide. At the time, we actually create a CloudFormation based deployment able to automatically generate a working auto-scalable JupyterHub instance on top of several Amazon Web Services, such as the EKS backplane, EFS, alongside with some other multiple services. And we actually open sourcing that CloudFormation stuff pretty soon. So it is actually already public in some repository, but we are still finalizing some stuff so people can have a really nice experience and not a ugly buggy one. So you should stay tuned because we are releasing that pretty soon. And it is actually pretty powerful because with just the click of the button or with just issuing a command in a terminal, you can deploy this JupyterHub on top of Kubernetes stuff in just a few minutes and without any further intervention. So stay tuned, we will release that pretty soon. But alongside with our JupyterHub instance, we needed some layer of persistent traceability and collaboration. And even when we have some sort of persistence embedded in our JupyterHub instance through the EFS layer, we wanted something more. And we actually wanted to know who is actually implementing changes in the assignments and when they are actually implementing those changes. This is why we were looking for traceability. And also we have several content creators collaborating at the same time on the very same course. So we needed some sort of collaboration workflow as well. So we decided to use GitHub repositories and the GitHub infrastructure to provide these three things. And we integrate that with our JupyterHub instance. Every of our courses has their own private GitHub repository, as you see in that picture. That repository is automatically generated for them at the very beginning of the content creation phase. And one of the most important things is that that repository has a predefined and functional default that makes for the content creator easy to actually customize the environment and eventually create the assignments. The other thing is that faculty and TAs, the content creators, can choose the course they are working on because we have several content creators contributing to different courses. They can launch the most recent image from this panel page in our JupyterHub instance for some specific course, develop the content using standard software engineering methodologies and tools powered by the whole Jupyter infrastructure. But let me go a little bit deeper and transition a little bit from the develop stage into the generated stage. And let me introduce this customized course deployment environment idea. As I said before, each course has their own repository, and in that repository there is a specific place where they can actually set up some specifications. They could be maybe adding some library for the specific course. They can do that, adding the specification through requirement files. We heavily use the Conda and Anaconda stack to actually support those kind of additions. But there is also a need for bigger changes. And if that's the case, we actually provide a workspace course-specific Docker file where they can actually implement the changes and request the things they actually need. This is one of the examples of that workspace Docker file. If you see the first line, you will see there the MADS notebook image. That is the default image we are providing by default. It's inherited from the Jupyter Docker Stack SciPy image, but with some MADS specific enhancements. All of our course images for all our courses are automatically generated and are inherited from that MADS notebook default image. That is because in that way we are sure that we provide a familiar, similar experience among all of our images, and that is useful for our content creators. But at the same time, we give them flexibility to actually modify the environment accordingly to the need for the course they are actually working at. And on another layer, this is also important to provide a unified and familiar experience when we are going to deploy these environments into the Coursera, the LMS partnered infrastructure. So the students can have this familiar and similar experience across all the courses they are taking. Just to go a little bit forward with the workflow, every time the content creator push to the remote dev branch, it is actually triggering a CI job that is actually supported by the code build Amazon service, which among other things, it is actually building the course specific custom image and pushing that image into our own Docker registry, which is also provided by the ECR Amazon service. So after a few minutes, they can actually stop their notebook server in our JupyterHub instance, and the next time they started, the new and the latest Docker image will be automatically pulled and available for the content creator to use. That actually means a really fast iteration in the development of the custom environment and ultimately in their assignments. If they want to add some specific library, they just modify the requirement files or the Docker file if they want a more profound change. And they go to a coffee, and then when they get back and restart the notebook server, they will see that library already installed in the image, so they can keep iterating in the development of their assignment. So that actually makes their life pretty easy, because they don't have to go outside of our infrastructure to be able to test their changes. The other important step, is when they are actually making pull requests from the branch into the master branch. That is actually when the merge happen. That is actually triggering a new CI job that, among other things, will generate what we call an artifact, which is essentially a zip file containing several things. For instance, other things files, but essentially they are containing the course-specific custom environment specification the LMS partner will build and show to the students eventually. Obviously, we have the course content there, such as lectures, data, notebook-based programming assignment, and obviously the corresponding autograders. But let me go a little bit further, and let me introduce this idea of common grading framework. This common grading framework actually permeates our whole workflow, and it is present not only on the develop stage but also in the generate and ultimately in the deployment and in front of the students. So to provide a unified and standardized experience at the time to create the programming assignments, we heavily use the nbgrader project. nbgrader is really great. It's one of the most popular projects to grade notebooks inside the Jupyter ecosystem. We wanted to choose one general standard tool to create the content, because that helps us in terms of scalability. If you think about having all our dozens of courses actually created their own programming assignments with their own tools and their own autograders, trying to support that scenario is really difficult, if not a nightmare. So we wanted to have a general and a standard solution for them to make also their life easier. And that actually also help us not only reducing the complexity, but also foster the knowledge transfer between our content creators, and that help us to actually have a really strong community experience at the time to create the content among all of our courses. So we have nbgrader present in this first stage, I mean the develop stage. But our CI system that I had mentioned before is able actually to validate the assignments on every push to the dev branch the content creator is doing. And not only that, our CI system is able to check if the content creator has followed the nbgrader workflow and philosophy. I mean, if they follow the documentation, if they, for instance, release the assignments, I mean, if they created the student version of the assignment, and that is pretty important because it actually allows the content creator to have a really fast iteration at the time to create the programming assignments. This is one example of that process. You have at the very first commits, very successful commits. I mean, the CI job runs successfully there. And eventually I did some changes introducing some new library and modifying the assignment. This actually happened very early. We are not doing this anymore. We were helping at the very beginning, but now we are doing some other fun stuff. And that actually failed because I forgot to actually release the assignment. So one partner actually get into the CI system, actually get the reported error, which was an nbgrader release error, was able to release the assignment, and eventually that CI jump succeed. We had the green button or tick, and eventually we merged that PR. So as I said before, this actually allows the content creator to have a really quick iteration in the development of the programming assignments. The other part which is important here is being able to provide autograders and provide those autograders in an automatic way. And this is important because we are using nbgrader in a sort of a standalone mode. Let me just grab my pen and draw some things thanks to the RISE chalkboard capabilities. As I said before, we are using nbgrader in a sort of a standard mode because of some of our restrictions, limitations, or constraints. We have our JupyterHub instance in one place, okay, and on the other side we have our LMS provider, okay. In our JupyterHub instance, the content creator is actually creating content using nbgrader, okay, and eventually something, will be deployed in our LMS partnered, and using nbgrader, the students in this case, okay, will be able to submit their programming assignments, okay, and nbgrader will be able to autograde those assignments. So we need a link between those two things, and that link is provided by our CI system. Okay, our CI system, when the content creator is pushing content to GitHub, okay, it will build something, which we call that thing the artifact that contains a lot of things, such as the course-specific environment. But our CI system is also developing, or is also building there, automatically generate autograders that once deployed in our partner, our LMS partner, they will be able to actually successfully autograde the students' assignments. So let me go a little bit deeper on that idea. As I said before, our CI system, among other things, is able to create these Docker-based and also nbgrader autogenerated autograders that once deployed, they can successfully grade the student submission. The LMS provides actually a custom Docker-based autograder infrastructure with a predefined entry point and predefined output and feedback mechanism. And our Docker-based and nbgrader-based autogenerated autograders consumes what the students' programming assignments are, and it autogrades those assignments using nbgrader autograding capabilities, and eventually pass through the generated feedback and score into the LMS system to eventually show those to the students. And this is again the link. I mean, the autograder specification the LMS is building, is automatically generated by our CI system as part of the artifact we create to be sure that the autograding process runs in the very same custom course specific environment. And we make sure that that autograder process have all the information available to succeed at the time the student is submitting their assignment. So, in summary, with this design, decisions, we have been able to deploy a robot system that can scale to create hundreds of different courses, supporting potentially thousands of students with minimal effort and maintenance burden to provide this Jupyter-based experience that is consistent across the whole degree. Furthermore, the use of open source and well-defined software component, particularly tools from the Jupyter ecosystem, allow us to create experience which can be used both within our partnered LMS platform as well as other platforms as needed. So, with that, I want to thank the whole MADS team and friends at the UMich for all their support, and I want to thank you for being here with me, and I hope you have enjoyed this talk. See you next time. Bye.